which allow you to represent two different related motions with respect to time. So we're going to have two equations. We're going to have our x function and our y function, but both of these are in relation to time. It's very important that you add arrows to indicate the direction or orientation along the curve. The arrows are on the graph, and you'll see what I mean in a second. So let's look at example 1. It says graph the curve defined by these two functions, x equals 3t squared, y equals 2 times t. They want us to use t values from -2 to +2. So the first thing we're going to do is create a 3-column table. And it's going to be t, x, y. And because it's telling us right here, my t values start at -2 and end at +2. -2, -1, 0, 1, 2. I'm going to make my 5 rows. Now we're ready to get started. And trust me, it goes a lot faster without a calculator. We don't need a calculator for what we're doing right now. For x, I'm going to take these 5 numbers, and the parameter for x says take 3 times t and square it. So let's do order of operations. What's -2 squared? What's 2 times 2? 4. What's 4 times 3? What's 4 times 3? 12. That's my first value. What's -1 squared? 1. What's 1 times 3? What's 0 squared? What's 3 times 0? 1 squared is 1. 3 times 1, 3. 2 squared is 2. 2 squared is 4. 4 times 3 is 12. That's my x values. Now we're going to do our y parameter, which says just take 2 and multiply it by t. What's 2 times -2? What's 2 times -1? -2, 2 times 0, 2 times 2, 2 times 1, and 2 times 2. Now we have our ordered pairs. This is what we're graphing. We no longer need this column. So on our graph, I want you to put a point at 12, -4. Let's do that. So that would be right here. Okay. My next point is what? 3, -2. 1, 2, 3, down 2, put a point. And then we have 0, 0. And then we have 3 up 2. And then I have 12 up 4. And you connect the curve. Now, one thing I want you to note, and if you did not do it yesterday, I passed out homework 19 yesterday, which I meant to pass out today, because that homework has this information on it, which I don't know why I passed it out. But if you did not get it, they're in the Thursday pre-calc slot. Now, when you graph this, you do not add arrows on the ends, okay? It starts here and it ends here. That's number one. Second thing, I don't know, unless I add arrows, the direction of the curve. So am I starting here and going down, or am I starting at this point and going up? Well, we know my first point is here, and the curve is traveling this direction, which is why we need to put arrows, a couple of arrows kind of showing the direction of the curve. And that is it. That is how you graph a parametric curve. Any questions? All right, let's look at example 2. Let's make our 3 columns, T, X, and Y. Now, where is my T parameter? Where do they want us to do our T's? From where to where? -3 to 3. This is where they want me to count. So I'm going to start at -3 and go down to +3. So I have 7 rows. To find my X, we have to take our T, square it, and then subtract 4. So I think we could do this, y'all. Let's do it. -3 squared is +9. 9 minus 4 is 5. That would be my first number. -2 squared is 4. 4 minus 4, 0. -1 squared is 1. 1 minus 4, -3. And then we're going to repeat. So that's my X values. My Y values, they just want us to take our T and divide it in half. So half of -3 would be -1.5. Half of -2, -1. Half of -1, -0.5. Half of 0, 0. Half of 1, +0.5. Half of 2, +1. Half of 3, 1.5. Now, after you make your table, because I want you to notice, I didn't put numbers on here for a reason, because you can decide what you want to count by. When I notice that my Y values are counting by a half, for me to make it easier, I'm going to count by a half on my Y axis. Which means for me, when I graph it, this is going to be that's going to be 0.5. This is going to be 1. This is going to be 1.5, and this is going to be 2. That's how I'm going to graph it. Because why make it hard for myself? I don't want to try to worry about putting points in between lines and stuff. So let's graph it, y'all. My first point starts at X is 5. And it goes down 1.5. So 1, let me count over. Okay. 1, 2, 3, 4, 5 down 1.5. That's going to be 3 hops down for me. And then at 0, I'm going down 1. And at, oops, going down 1, which is 2 hops for me. And then at -3, 1, 2, 3, I'm going down to -1/2, which is 1 hop. -4, 0, and then I'm going to come around the curve. So here's my points. This is my curve. Notice again, there are no arrows. If you put arrows, you got to test a week from today. If you add arrows on the ends, I'm taking off a point. No arrows on the end. The arrows are on the curve. So when I add my arrows, I'm adding them actually on the actual curve. You need at least 1 or 2. 1 or 2 is enough, really. You don't even need to put 3. So I'm showing that this is the direction that the curve is going. All right, go to page 10. And we're going to skip down to the last graph. All righty, let's do it. Make our 3 columns. And then we're going from -2 to +2. And I skip. All right, I'm going to give you all a minute. Find your X and Y. For X, you're going to square T. For Y, you're going to cube T. Go ahead and find your numbers. Okay. So we got 4, 1, 0, 1, 4. And then this one I'm multiplying by -2. Who got that? Your table match my table? No? Did I mess it up? Which one I mess up? The who? -1 cubed. There you go. I did that on purpose, y'all. I'm just making sure y'all paying attention. Okay, now we right, we good? I don't know why I thought it was 2t. 2t squared. No, it's t cubed. All right, so now this is out the picture. Let's graph it. Okay, positive 4 down 8. Okay. This one's kind of weird the way it doesn't really look like a curve when you connect the points. I don't know how to describe that. Now we just need to add our arrows. Wait. That's not right. Okay, it's right here. Okay. All right, so if you don't add arrows, that means that we don't know which way it's going. It's not coming this direction. Don't copy that. It's starting here. This is the start of my curve. This is the end. So my direction is going that way.